Today we're going to be solving systems of equations by substitution. We're working with systems of linear equations for now. So an example of that would be if I have two equations whose graphs would be lines, such as x minus y equals 6 and 2x minus 3y equals 20. You'll usually see these two equations with that curly bracket, meaning that they go together. Now, when we solve these systems of equations, what we're looking for is a combination of x and y values that will simultaneously make the first equation true and the second equation true. Now, realizing that we're going to be graphing two lines, there are only so many ways that this can happen. These systems will be two lines for now. We will work into graphing systems that have a line and a parabola, or two parabolas, or maybe a circle and a parabola. At this point though, these systems will be two lines, so their graphs could do one of the following. We could have two lines that intersect at one point. If the two lines intersect at one point, then the solution to the system is the ordered pair where they cross. So that will be in the format of an ordered pair with two numbers. Now this could happen in any way. The two lines could cross at angles like that. The two lines could be crossing at a right angle. It doesn't really matter which way they cross, as long as they intersect in one point. There's another possibility for my two lines. The two lines could be parallel, like the lines on my notebook paper. So they could be parallel. And since the solution to the system is where those two lines cross, this type of system has no solution. There is a third possibility. Well, by the way, the parallel lines don't have to both be horizontal. They can both be slanty, they can both have a negative slope or a positive slope. They could both be vertical. They could be any of those kinds of parallel lines. The third possibility, though, is that those two lines could be the same line. And we call that, when you have two of the same line, coincident lines. Now, when we have two lines that are the same, it's virtually impossible to tell because they're just right on top of each other. But it would just be the same line right on top of each other. And since the solution to the system is the point at which the two lines cross, this type of system will have an infinite number of solutions. Now that's what happens graphically, but we also need to talk about what happens algebraically when we solve these, so that we'll know what type of system we have as we're solving. Algebraically, I'm going to write that in green. Algebraically, if you have two lines that intersect at one point, when you solve, you are going to get that x equals a number and you're going to get that y equals a number. And you'll put those into ordered pairs. If you have a system that has no solution, in other words, the lines are parallel, you will get something that could never be true. So you will get a false equation. Oh, something like 0 equals 7 or 4 equals 33. Something that's just always false. But if you get a system that has an infinite number of solutions, you will get an equation that is always true. Such as 4 equals 4 or 0 equals 0, like a reflexive property. So that's what you're going to be looking for as we go into the algebraic steps for solving these systems of equations by substitution. So let's look at what those steps are, and then let's look at some examples of solving using this method. So here we have our steps to solve by substitution. Maybe we should start a new page. Okay, steps to solve by substitution. The first thing that you need to do is you're going to rewrite one of the equations so that you have either x equals or y equals. So we're going to rewrite one of the equations so it is in the form y equals or x equals. And it doesn't really matter which way is which, you just want to pick the easiest one. So you might make yourself a note to pick the easiest one. Pick the easiest one. And also, just a reminder, this will not give you a numerical answer. This is just going to give you a rewritten equation. It's still going to have both variables in it. The second thing you're going to do is substitute that expression into the other equation. Don't substitute it back into its own equation. You want to substitute that into the other equation. Again, this is not going to give you a number. Right away, but after you solve it, this will give you a number. This will give you a numerical value after you solve it. Once you have the value of that first variable, you're going to substitute that value into the equation you got in step 1. Okay, that's going to give you the other variable. So this gives you the other numerical value. And then we're going to want to take those two values and write the solution as an ordered pair. Remember that there are those two exceptions. If you're going to have no solution, you will get something like 0 equals 5 in step 2. Or if you're going to have infinite number of solutions, you'll get something like 0 equals 0 in step 2. So once you've found that, if you get 0 equals 0 or 0 equals 5 or one of those true or false equations, then you're finished and you can just say there's no solution or an infinite number of solutions. In the next video, what I'll be doing is going over 2 examples of solving systems of equations by substitution and then looking at their graphs.